All right, this is from the chapter 4 review in Stewart. This is a limit question. And so this is going to end up in my L'Hopital's rule playlist because this does turn into a L'Hopital's rule problem. First, though, let's kind of see why, because you don't always know, right? This is kind of mixed in with some other limit questions, and you don't necessarily know that it's going to be L'Hopital's rule up front. So the first thing you're doing with this is you're trying a direct substitution approach. Okay, so let's check that out. If you plug, pi from the left kind of into this piece, we're looking at something a little less than pi minus pi. So we're going to get like a close to 0, right? I'm going to write this here, and be just careful about like what kinds of things you write, like in the main part of an exam or something, But yeah, that's basically approaching 0 from the left. And you write something like that kind of lightly as like a notation right by the problem maybe, because we're not writing equals here. And then when you kind of look at this piece, now you're thinking about the cosecant of something, that's just a little less than pi. And so if you kind of picture on the unit circle, this can be a little confusing to think on the unit circle when you're talking about like left versus right. Remember, from the left means on the number line. So less than pi is what we're talking about, okay? Sometimes, especially if you're looking at like the top or bottom of the unit circle, if you start at 0 and you're going to like pi, and you're like thinking about pi over 2 from the left or the right, it can be very confusing because from the left makes you want to go here, but that's actually from the right because these are the greater theta values or x values, right? From greater values. So just careful with that. In this case, since we're talking about pi from the left, it's maybe a little less troublesome. Well, again, if you kind of turn your head sideways, though, you might be tempted to think over here, but that's not right. From the left means from lesser values, lesser than pi, which is here. Okay, so we're talking about a value really close to pi for the angle, but less than pi. And so cosecant's 1 over the sine. Sine's the y-coordinate. So the y-coordinate there is approaching 0 from the positive direction. So we're talking about very tiny positive values for sine of x. So we're talking about like 1 over 0 from the right is the idea, right? And so this is like a L'Hopital's rule situation. It kind of turns into like a 0 over 0 when you multiply those, but it's not really right now, right? This isn't written as a fraction, right? This is really more like 0 times infinity. This is 0 from the left, so a negative 0, right? A little less than 0, times a positive infinity. So it's 0 times infinity, which is an indeterminate form, but not a L'Hopital's rule one. Okay, so to use L'Hopital's rule, we need to get it into 0 over 0 or plus or minus infinity over plus or minus infinity, right? Into that form. Now, again, just careful, like you don't ever want to say that the limit equals one of these two things because these aren't things you can equal. And, especially if this limit ends up having a value, then you'll have a false statement on your hands, right? Now, if it turns out that the limit does not exist, writing one of those is a little less problematic, but still kind of, there's like a syntactical issue there too. All right, anyway, let's rewrite the limit as x approaches pi from the left. Okay, I'm saying that this equals this. I'm going to keep the x minus pi on top. That's a 0. And I just, what did we do? We turned the cosecant kind of into a sine, right? That's how we got the 0 on the bottom. So we're just going to rewrite it that way. Make it sine of x on the bottom, right? That's the same thing as times cosecant of x if we do divided by sine of x, right? And now we can write, one of two ways now to justify using L'Hopital's rule. You either want to say is of the indeterminate form 0 over 0, or show those limits separately, which I think is generally the preferred way. The limit as x approaches pi from the left of x minus pi is 0. It's 0 from the left, that's true. I'm just going to say it's 0 though. And the limit as x approaches pi from the left of sine of x. Well, the limit as x approaches pi of sine of x is definitely also 0. So that's it. That's all you need in order to justify the use of L'Hopital's rule. So I'm going to shrink this up a little bit here and get that kind of out of the way. Okay. And so now I can say this equals, and I just like to really connect my equal statements because I kind of have these like sub statements sort of in here, right? These are used to justify what I'm doing. So this limit equals the limit as x approaches pi from the left of, and now we can take the derivative of the numerator and the derivative of the denominator of that limit. Limit of the derivative of the numerator is just 1, right? Pi is a constant, and then the derivative of the denominator is cosine of x, and so we're good there. And I recommend justifying in your justification. I mean, it doesn't, if the directions say justify on an FRQ on the AP exam, for instance, we've actually already done enough by showing this, but I would say, by L'Hopital's rule. So on the AP exam, unless they specifically say so, they don't make you name the theorem or the rule, whatever you want to call it. But they do want you to give the prerequisite justification for using it, right? So that the logic is true. But I think if you know it, you should absolutely name it. Anyway. At this point, it's no longer an indeterminate form. You can now do direct substitution. It's 1 on top, and then when you plug in pi on the bottom, it doesn't really matter from the left anymore, right? We're looking at the cosine of pi, basically, which is -1. And, from both left and right, it's going to be -1 in that case. And so it's just -1. So that's it. It ends up being a simpler problem at the end because the L'Hopital's rule only needs to be done once, and the derivative isn't that hard. But seeing where to go at the beginning can be tricky, especially if you get creeped out by cosecant of x, things like that. So anyway.